Find this page before going any further with this video. Today we are going to talk about solving one-step inequalities, and first we're going to define what it means to be an inequality. I'm going to zoom in here so we can add a few notes. You can add these to the margin of your paper. So far this year we have solved equations. The equations are combined, two equal statements are combined with an equal sign, and that looks like this right here. We also are going to talk about inequality symbols, which look like these. And you may have seen these before, you probably have, and we're going to talk about what these symbols are. We can start with this end one right here. This is an equal sign with a line through it. And so this means not equal to. So that is what you would use when they're not equal to. You kind of probably remember these alligator symbols from elementary school or middle school. This is a less than sign. This is a greater than sign. When this line is being drawn underneath, that means or equal to. So this is a less than sign with this line underneath it. It's less than or equal to. This symbol right here is a greater than sign with the line underneath it. That means it's greater than or equal to. So make sure you add those labels that I have right here, just like we talked about. So solving inequalities is exactly the same as solving equations, except one thing. We have to remember that if we divide or multiply by a negative, we have to reverse the inequality sign. And I'll show you some examples of this in our problems. All right, so let's just take a look at this first one. This first one, if you're going to solve this, and I'm going to actually rewrite this underneath so that I have some room to solve it. I have negative 12 is greater than x minus 7. If I'm solving this, I am trying to get the variable by itself. I'm trying to get x by itself. So if this had been an equation, I would say, oh, I have this minus 7 attached to that. And to get rid of that, I can add 7 to both sides. And I can do that. Negative 12 plus 7 is negative 5. And that cancels out over here, and I'm left with the x. So as long as I'm not multiplying or dividing by negative, my inequality sign stays the same. So this is, I always read it from where the variable is. So I would be thinking of this as x is less than negative 5. But I like to have the variable on the left. So I'm going to rewrite this, but I have to be careful because I don't have an equality. If I have an equation, I can switch sides without thinking about anything. But if I move the x and the negative 5 and I switch sides like this, I have to switch the inequality sign because it changes the value if I don't. This little part right here is by the x, which means when I rewrite that, that little part has to stay by the x because the relationship has to stay the same when you switch the sides. Now we need to graph the solution set because there's not just one answer, there's infinitely many answers, and we need to show that on a number line. So we need to find negative 5 here on our number line. And so I don't see a negative 5 on this one that's pre-printed on your paper, but I know it's between negative 6 and negative 4. So I know that that's right here. This is the negative 5. And this is something that you may not have seen before, but our solutions are x is less than negative 5. It's not less than or equal to. So it does not include negative 5. And how we show that it's everything right up until negative 5, but not including it, is to draw an open circle there, to draw attention that the negative 5 itself is not included. And we actually do that anytime we see less than without the equal to or greater than without. We call those open circles. And we would have I'm going to just put an example up here at the top with our other notes. If it includes the equal sign, we use a closed circle and we graph it filled in like this. So you might want to put this up at the top just to remind yourself as we go through that. So I have an open circle here. And if it's less than, it's all of these values to the left here. And then I want to put an arrow to show that it goes on forever. It goes way over here to negative infinity, all the way down. But we don't have to draw a line longer than that. We just need to show that it's going in that direction. And so any one of these answers, -6 would make this inequality true. -10 would make it true. -8.5, all of these values would make this inequality true. So the solution set are all of these values that are to the left of -5, right up up until -5, but not including it. So let's take a look at number 2. And again, I am going to rewrite this question underneath just to give myself a little bit more room to write and solve. So -1 plus r is greater than or equal to 4. And if I'm solving this, I want to get the r by itself, which means I need to get rid of this -1. And the inverse operation for -1 would be to add 1 to that. And over here, I have like terms. So the -1 plus 1 nets out to be 0, and I'm left with r. And my 4 plus 1 gives me 5. I did not multiply or divide by a negative, so my inequality stays the same. So this one's a little different. This is saying that r is greater than or equal to 5. So the first thing I need to do is find 5 on my number line. And if I'm looking around here, I see 5 right here. 5 would make my inequality true. 5 is greater than or equal to 5. So 5 is part of my solution set. And so I am going to graph this with a closed circle, that filled in circle, to show that 5 is part of my solution. Now, 6 is also greater than or equal to 5. So I have to include 6. 7 is, 8 is. So everything going to the right is part of my solution set. And greater than, again, if my variable's on the left, I can use that inequality symbol to follow this over here. And so this is the solution. So there's not just one answer like there is for an equation. Because this is an inequality, it's all the numbers that are 5 or bigger, even the fractional ones like 8.5 or 10.5 or 1,000 over here. So this, all the answers all the way to positive infinity, starting at 5, are part of this solution set. So I zoomed out here. Let's look at a different type of problem. So we've done some adding problems. Subtracting will be the same. Let's look at when we have some multiplication. So I'm going to zoom in down here, and we're going to take a look at number 9 and number 10. And so I'm going to rewrite those. So from looking at number 9, I have -3x is greater than 3. So I have a problem that's attached. It's -3 times x. And so to get rid of multiplication, you divide. So I'm going to divide by -3. And I have to remember here, I am dividing by -3. That means I'm going to switch my sign. So right there, because it was negative, I'm going to go from the greater than that I have right here to a less than, because I divided by the negative. That's what's happening right here. Put a big arrow there. Because I divided by the negative, I have to switch the sign. So you might want to write a note, switch your inequality sign. You might want to write a note to yourself on there so you remember to do that. So my -3's cancel out, so my coefficient is 1 now. So I have x is less than 3 divided by -3 is -1. So I need to find -1 on my number line, and I see that that's right here. And because it's not included, this is less than, not less than or equal to, so it does not, -1 is not less than -1. It's not part of our solution. So I need to put a big open circle here to show that it's not included. Less than means I'm going to shade to the left. If you're ever uncertain, you can test a point. I like to test a point in the original, because that way if I made a mistake in my inequality sign down here, I catch that. We can test it in both places. If I put a 0 here, I'm going to test this point right here, which should be false. Is 0 less than -1? 0 is not less than, it's greater than, so that would be false, and so it should not be shaded over here, and it's not. If I test in the original up here, -3 times 0 is greater than 3. -3 times 0 is just 0. 0 is not greater than 3, so again, this is false, and so it is not part of our solution. If 1 point is not part of our solution, then no point on that side is. So our answers are all the values that are less than -1 going all the way to negative infinity. Let's take a look at one more. So let's look at number 10. I'm going to rewrite it right here. I have n divided by 3 is greater than 3. And n is divided by 3, so the inverse multiplication of dividing is multiply. So I'm going to multiply both sides of my inequality by 3. I'm not multiplying by negative, so I don't have to do anything different than an equation. So this 3n divided by 3, that cancels out, and I'm left with n is greater than, now 3 times 3 is 9. So I'm going to find 9 on my number line, and so I'm looking here, I see 9. It is not included, so I have an open circle, and this is a greater than, so I'm going to be shading everything to the right. So all of these values to the right make this inequality, this original inequality or this simplified inequality, true. And so we'd put an arrow here, so everything right up to positive 9 and to the right would satisfy this inequality, so they're all part of our solution set. So you are going to simplify your inequality and graph the solution set for the rest of these problems.